Hi, welcome to this lecture on mathematical methods for biologists. In this lecture, the topic that we are discussing is the following: integration, graphical understanding. How to use graphs to understand integration. That's what we will discuss. We will answer this question: how do we use graphs to understand integration? So, to do this, let us think of the context that we have. What we learn so far is we have some function which is the slope itself. So, we call it m so far. So, we had a function, so the slope, we called it m. We could also call it slope itself is a function. So, if the slope is 3, which is not a function of x, so but the slope is 3. So, if my function is a constant which is 3, the integral that I want to calculate is integral f dx, which is integral 3 dx, and we know how to find and what is the answer to this using the formulas that we learned. Now the question is, if we plot graph of this slope itself, the function which is the slope, if we plot the graph for the 3 function, can we graphically understand the integral? And it turns out that integration has a graphical meaning. From the graph, we can calculate the integral in a particular way, which is a very interesting way or very interesting idea. And the idea is the following. So let us start with the same example, that you have this function or a slope which is 3. We want to calculate the integral of this function 3 dx. We already know the answer to this. Now let us frame the same thing in a slightly different way. So let us take this function 3 as a, let us take this as a plot. So let us plot f is equal to 3. Let us plot this. So we will plot f is equal to 3. What is the plot? It is so the function is, so this is our xy axis, and the function is just a constant. So what is, if it is a constant, we know that it is just this. So this is 3. So this is our, so this is f of x versus x. The function is independent of x. Whatever be the value of x, the function is 3. Our function is 3. Now we want to integrate, we want to calculate integral 3 dx. So it turns out that integral 3 dx, so we learned that dx is a small interval. So if I just take a small interval here, so this is my small interval. So if I take this small interval, and this is my 3. What is this integral 3 dx? Integral, this is my dx, this small area, small length. 3 is this height. This is 3. So this height times this width, which is dx. So 3 dx will essentially turn out to be the area of this. This shaded area will be 3 dx. Now integral 3 dx, is essentially summing this area. So if I calculate this area from, let us say, 0 to some point x, which is 5. If I calculate this area between 0 and 5, that is this total area, if I just calculate this whole area which is shaded here, which includes the whole green shaded part, this area is equal to integral from 0 to 5. Area under this. So what am I, the claim here is that if we integrate this function f from 0 to 5, and if we calculate the area under this, it will be the answer for this integral. So to understand this, let us little bit think about the old example of polymerization that we discussed. So let us come back to this example of polymerization, depolymerization that we discussed in the previous lecture. What did we say? We said that you have this polymer which is polymerizing with some rate Kp and depolymerizing with some rate Kd. Kp is the rate of polymerization, how many monomers per second will add. Kd is the rate of depolymerization, which says how many monomers per second it will dissociate. And we wrote that dl by dt, the rate of change of length. How does this length change with time? That is dl by dt. How will this length change with time? dl by dt is equal to Kp minus Kd. So let us say Kp minus Kd is 3. So if I just take Kp is equal to 5 monomer per second, 5 monomer per second, and Kd as 2 monomer per second, Kp minus Kd will be 3 monomer per second. So if I know that dl by dt is 3 monomer per second, we saw that this would mean that dl is integral t dt. So now the question we have is, what is L of t? This is the question that we want to answer. If I know that this dl by dt is 3, what is the length at any time t? And if you want to answer this question, it turns out that this is essentially is a area. If I draw a curve, so now this can be, this L of t can be found by drawing the curve of 3, which is the line, and finding the area up to the time that we want. So let us say what we want to answer is this following question, that we have this dl by dt is 3 and we want to calculate the length at any time. So after 10 minutes, what is the length at after 10 minutes? We know that the length at 0 minute. So right, so let us assume we know how to do this using a formula. We will discuss this. How do we do this graphically? So it turns out that the way to do this graphically is to plot this function. If I consider dl by dt as my function, I can plot it. So let us plot dl by dt. So I will plot my function. So this is 3. This is my dl by dt. This is my slope function. This is nothing but my velocity function. And what I want is to integrate this up to, starting from a time to 0 up to a time 10. So 10 is the time that we want to calculate the length at. So take this point, which is 10. So here this is time. The x-axis is time, t. So if I want to calculate the length at time, I take this and I find the area from 0 to, so if I find this area which is shaded here, which is between 0 and 10, if I find this area, which we know that the area is going to be 3, which is the height. So this height is 3 and this is 10. So this will be, area will be 30. We know that area is going to be 30. And this answer L of 10 will also be 30, assuming that the L of 0 is 0. So this is assuming the L of 0 is 0, the answer is 30. So the integral from 0 to 10 dl dt will turn out to be the area under this curve, which will be the answer for this length. So if I integrate this, I will get length, and which is nothing but finding this area under this curve. So what is the claim here? Let us repeat the claim once more. The claim is that integrating this function and calculating the length is same as finding the area under this function v, which is nothing but a slope function. So if we take the slope function v and plot it and find the area under this from 0 to 10, which is same as integrating this and getting the integrated function L at 10. So this is the claim. So let us understand this in a different way, which is this thing is also called a definite integral. So the way to represent a definite integral is put two numbers here at this ends, 0 to 1 f of x dx. Integral f of x dx 0 to 1. These two numbers are called lower limit and upper limit, which essentially says that if this was time, if we come back to this example, what we did here is nothing but integral 0 to 10 v dt, and this is what this is, integral 0 to 10 v dt. So let us re-understand this. Let us say this once more slightly differently. So what we have is dl by dt, and we wanted L at 10. This is what we want to calculate. To do that, we plotted the function 3 from 0 to 10, and we calculated this area under this curve, which is the function 3. So area under this curve 3, this is our v function. So if v is equal to 3, and which is nothing but dl by dt, and we want L, which is v dt integral 0 to 3. So it turns out that the L we want at 3, if we wanted at 10, this will turn out to be integral 0 to 10. So this is called a lower limit and this is upper limit. So this is the way to represent. I want to calculate the time. If I know the time at 0, I want to calculate, if I know the length at 0, I want to calculate the length at 10. And this is essentially the way to write it is integral 0 to 10 v dt. If I do this, I will get L at 10, I can get, and it will turn out to be 30. So that's what we did here, and let us take a function, says another example, f of x dx, whatever be the function. If I want to integrate from 0 to 1, this is nothing but finding the area from 0 to 1. And if I take f of x as 2, this definite integral can be written as, integral f of x can be written as, integral can be written as a sum of f of xi times dxi, where f of xi is the height at some location I, and another. So if I divide this into many locations of width dxi, dx1, dx2, dx3, dx4, and I can calculate height versus width, which is nothing but the area of each of these small boxes, and sum of this area, the first box area plus the second box area plus third box area plus fourth box area, which being a rectangle, this area will turn out to be the total area of this, and which you can calculate. So 0 to 1, this is 1, 1 times 2, and this area will turn out to be 2. So, and if I do this definite integral 0 to 1 2 dx is what I have to do. The way to do this is take this 2 outside and find out the integral of dx. Integral of dx is x. Now if I want to do this from 0 to 1, the way to write is x 0 to 1, and to applying the limit is the following. First substitute this upper limit instead of x. So 2 times 1 minus 2 times the lower limit 0, and the answer will turn out to be 2. So in other words, let us go back to the example of dl by dt once more. What we had dl by dt, which is 3. In the earlier thing we wrote dl is equal to 3 dt, and we integrated. When we integrated, we didn't put any limit, there was no number. We just wrote here this as L and this as 3t plus a constant. This is called an indefinite integral. Here the constant could be any number, but if we want this to calculate between 2 points, that is, for all physical processes you want to calculate the length at a particular time given the length at some other time. So what we want is L of 10, the length at 10 minutes given L of 0. So to get this, the integral can be rewritten as integral 0 to 10 dl by dt, which is nothing but integral 0 to 10 3 dt. So you can write dl by dt times dt. So this can be written as integral 0 to 10 3 dt. So how to calculate integral 0 to 10 3 dt? So this integral is called a definite integral because it has two limits. This is lower limit, this is upper limit. So how do we calculate this integral is an important point that one should remember. Let us do this slowly. So we have integral 0 to 10 3 dt. This is what we want to calculate. This is called a definite integral. The meaning of this is that if I draw a graph of this function 3, the area from 0 to 10, this shaded area, between 0 and 10, this is the physical meaning of this. This is the graphical meaning of this. So integral 3 dt 0 to 10 is nothing but this area between 0 and 10 with the y being 3, the function being 3. So now we know that the answer is 30 because of the area. Now this integral, which is called a definite integral, it has two limits. This is called a lower limit. So this is called a lower limit, which is 0, and this is upper limit. So the lower limit is 0, upper limit is 10, and we want to calculate integral 0 to 10 3 dt. So the way to do is the following. We know that integral 3 dt will be just 3 is a constant and integral dt will be t. So this will be 3 times t. We would typically write a constant plus a constant if I don't have this limit. But see, if I have this limit, the way to express is this. I write 0 and 10 here. That is, I have this answer which is integral of 3 dt as 3t within the limit 0 to 10. Within the limit 0 to 10, we have this 3t, and if I apply this limit, how do we apply this limit? To apply this limit, first take wherever t substitute 10. So 3 times 10 minus wherever t substitute 0. So 3 times 0, which is 0. So which is nothing but 30 minus 0, and the answer is 30, which we knew from the graph itself. So this is the way of calculating a definite integral. So what we did, we did essentially a method. We did a method of calculating definite integral. Definite integral. That's what we did. We essentially calculated definite integral. So this is called the definite integral. So basically, if you have integral f of x dx, so which is 2 dx in this case, and this is minus 2 is equal to 2 0 to 1 dx, and dx as integral x within the limit 0 to 1, and I apply the limit first wherever x I substitute 1, so 2 times 1, wherever 0 I substitute x I substitute 0, so 2 times 0, so 2 minus 0, the answer is 2. So this is the way to calculate definite integrals. Now to understand this, let us do one more generalized thing. If I have in general this function df by dx, so what we have, we typically will have m, which is dy by dx or df by dx, and this is what we have, and we want to calculate integral some point a to b between 2 points m dx, which is nothing but integral sum a to b dy by dx. We know that integral of dy by dx is y. Now since we have this definite integral, this limits a and b, the way to do this answer will be y evaluated at x equal to b minus y evaluated at x equal to a. That is, let me write this properly. That what does it mean? Y at x equal to b, substitute wherever x as b, minus y at x equal to a, substitute wherever x where there is a. So this is the answer. This is the thing that we should remember. In general, if you have a function dy, if slope dy by dx, integral a to b dy by dx, the definite integral will be y at b minus y at a. That is y at x equal to b, wherever x substitute b, minus y at x equal to a. So this is an important point, important thing that you should know in integration. Now we did so far a function f which was a constant. Our function was just 3. Now we could take any other function which is not a constant. So let us take the next simplest function which is not a constant but a straight line. So let us take our m, which is dy by dx. Let us take it as 3x or 4x or some other number. So now here the slope is a function of x, 3x. Now I can plot here this thing. I can plot here m versus x. If I plot m versus x, what will I get? I will get a curve which will be curve of 3x. So this is my m is equal to 3x curve. If I want to integrate this from 0 to 3, so let us say I want to calculate integral 0 to whatever 10 m dx, which is 3x dx. If I want to calculate this, if I want to calculate integral 0 to 10 3x dx, you calculate, take these 2 points 0 and 10 and calculate the area under this. If we just calculate area under this curve 0 to 10, if I can calculate this shaded area, between 0 and 10, this is my 10, this will be answer to this question. Answer to this question will be area between 0 and 10 for curve 3x. So take the curve 3x, mark 0 and 10 and find the area under this. That will turn out to be the answer to this integral. So answer to this integral 0 to 10 3x dx is this area under this curve. We can calculate this area. So let us look at here for another function. So you have f of x equal to x, and if I calculate this area integral 0 to 2x dx, we can do this calculation, and if I calculate this area, this will turn out to be 2. So now how do we do this? We can also do this as a definite integral. So what we want, in one case we wanted integral 0 to 10 3x dx. This will turn out to be, we know that integral 3x dx is 3x square by 2 is the answer for 3x between 0 and 10. This is the limit we want. So we apply the limit 3 by 2 times x square, which is 10 square minus 0 square. So this will turn out to be 3 by 2 times 100, which is 150. So the answer of this will turn out to be 150, and the answer of this one 0 to x dx will turn out to be 2. So which is again can be done. You have x square divided by integral x dx can be written as, so let us quickly do this, integral x dx integral 0 to 2 x dx will be x square by 2 0 to 2, and this will be 4 x minus 0 divided by 2. If I apply 2 here, 2 square 4 minus 0, and this will turn out to be 2. So that is the answer, and that's what we got. So to summarize, what we did now is we discussed a graphical method. We said that a definite integral is area under the function, the slope function that we have, and this can be used to solve various problems. Just like we solved the polymerization problem, we will do many problems, and many things in biology is essentially writing down this integral, and actually solving the problem is essentially writing down this integral and integrating it and calculating this area and obtaining the function, and that will help us in understanding many problems in biology. With this, we will stop today's lecture and continue in the next lecture.